So we're going to do problem number 6 in your classwork about population growth. It says that this table shows the population of a city every 10 years since 1970. So we're looking at the size of the population every 10 years since 1970. So you'll notice in the table it's a little bit different. We've got years since 1970 is X and population in thousands is Y. So we know that this is X and this is Y. But then what does it mean here when it says 0? Well, since it's years since 1970, what it means is that it has been 0 years since the year 1970. So that first measurement is in 1970. So this year is 1970, right? And then years since 1970 here, 10 years past 1970 would be 1980. Here, 20 years past 1970, it'd be 1990, right? And 30 years past 1970 is the year 2000. And so on, right? 40 years past 1970, 2010. Okay? So that helps us put that in context. Sometimes they'll give you the year and they'll want you to figure it out. Sometimes they'll give you the year since a date and you kind of have to use that information. So then it's asking us to find the quadratic model in standard form from the data. This is straight up our Desmos work. We go into Desmos and I've already done this. I hit the plus sign to create a table. And then I entered this data in. You can see I've got my 0 and 489, which is right there, 0, 489. Then I've got 10, 801, 20, 1,202, 30, etc. Now you'll notice that I put them in without the commas. I left one comma in here, and do you see how it gives me an exclamation point? Desmos does not like commas, so we do not include the commas in our table. Just leave them out, it'll be fine. Once we've done that, again, you see this plus sign. If you hit zoom fit, it'll help you find the data points in your curve. And you can see we've got a curve upward here, such that when I add a regression, and I don't want a linear regression, because this is a curve, we're going to change this to a quadratic regression in our dropdown. You'll notice that that fits our data really well. So here where it's asking us the equation, this is our linear model, right? Or excuse me, our quadratic model right here. The equation, y equals, and then our value of x squared, our value of x. You can just copy this down and write that in here where it's asking you to find the quadratic model, because our quadratic model is the equation of the line that matches that. Now I've just copied and pasted it in here. You can just write it down, okay? Now we have to do a prediction. It says, using this model, what will be the estimated population in 2020? Okay, well, 2020 is not one of our options here, but the first thing that we want to do is the number that we have been given, the value that we're looking for, 2020, is an x or a y. Well, years is x, and we know 1970, 80, 90, 2000, 2010. We don't know 2020, but 2020 would be the next one in the line. So I'm just gonna add a little thing up here that says 2020, which is what we're looking for. And 2020 happens to be how many years since 1970? Well, that would be 50 years since 1970. Okay? So what we're going to put in for our prediction is we know x. We know x is 50, right? Because 50 corresponds to the year 2020, and that's what we're interested in. We don't know the population or y. So we're going to go over to Desmos and put in the one that we know. And the one that we know is x. So I'm going to type in x equals 50. This will help me find the one that I don't know. If I zoom out a little bit here, you can see that when x is equal to 50, it crosses our quadratic equation model right here. We know that if it's been 50 years since 1970, then the population has to be 4,177.4. So when the estimated population is for 2020 has to be equal to this value of y. So again, we figure out what x value, how many years that is past 2020. We figured out that 2020 was 50 years past 1970, so a 50 for x. And then once we figured out that we needed a 50 for x, we could put x equals 50 and find the y value of 4,000, almost 4,200. And then we just say that that is our estimated population.